All right, what's going on, guys? So, we're here with another video. Hopefully, and I just want to point this out before I begin any of the problems. I'm gonna write it down actually. Um, the air conditioning is right in front of my face, but up here in the Northeast, it is ridiculously hot. So, um, I don't want to turn it off. I don't want to turn it off every time I make a video. It's gonna get really hot up here, and yeah, I'm gonna leave it on. Hopefully, it's not too annoying for you guys. I try to lower the power of the microphone. I took out the 48-volt button and took out whatever air meant, um, and hopefully it's not too annoying. And although I do have the out the what is it called, the input level a little high, but hopefully it's not too annoying and you guys aren't pressed over it. But anyways, we're continuing with the chain rule here. So this is part 4. We're going to go over, let's see, I have 1, 2, and 3 problems here. And these problems take quite a bit of time. So hopefully we can get through this sort of quickly, but I don't want to go over it too quickly. All right, so let's go. So here we have two functions, and they're being multiplied by each other. So you have to use the product rule first. So let's go ahead and use that product rule. So what that means, again, I'm going to explain one more time. When you have two functions being multiplied by each other, the first one that you write, it will be f of x. So you're taking f of x, and then g prime of x. And then you add it, and then you rewrite g of x without the prime, and you're going to write f with the prime now. So f prime of x. And that is it. That is the product rule. So we're going to assume that f of x, I haven't done this with every problem, but I'm going to do it for this one. I'm going to write down that f of x is going to be my negative, or my e to the negative e to the negative x. What am I doing? Twisting my tongue here. And my g of x is going to be cosine x squared. All right, so let's go ahead and write that in that rule that I have, or in that form, like the rule here. My f of x is first, so I'm going to write e to the negative x times, and I'll write cosine in parentheses because I like to write the one with prime inside parentheses. And then the prime symbol here. And we're going to add, and then we just rewrite the cosine again. Okay? And then my prime or e to the negative x. And don't forget the prime there. All right, so all we did was we followed this rule. Okay, we wrote f of x, g prime of x, plus g of x, f prime of x. And that's it. All right, so nothing to do with the first e of x, so we write it down. And all we need to do here is take the derivative. Now, this is where the chain rule comes into effect. So I'm going to write this in blue, but then I'm going to erase it. So hopefully you guys write it down. All right, push this to the side. So we have cosine x squared, and we're taking the derivative of that. And again, I'm going to erase this. And so we use the chain rule. We have to take the function of the derivative of the outer function. And so the outer function is what's not inside the parentheses, so not this. So essentially what we're doing is just taking the derivative of cosine, and that is negative sine. So what we're going to do now is we're going to rewrite what was inside the parentheses, which was x squared, and then we have to take the derivative of what was inside the parentheses, which was x squared. So the derivative of x squared is negative. Well, the derivative of x squared is 2x, but when we rewrite it, it's going to be negative sine x squared times 2x. Now, you could write 2x is also equal to 2x, or negative 2x sine x squared. All right. So that is what's going to go over on the left here. So that was the derivative of cosine x squared is, let's go ahead and put the negative 2x here and put the sine x squared. We just used, I just moved over the 2x that I have here, moved it out on the outside, and left the sine x squared on the right here. All right, so time to erase this in red. And we're going to move on to the right side of the addition sign, the second term. All right. Okay. So we're going to add, and we're going to rewrite cosine x squared. Okay. Nothing to do there. And then we have to take the derivative of e to the power of negative x. Again, you have to take the chain rule. And what that says is that we have to take the derivative of the outer function. The outer function is just e, and that just stays as e to the negative x for now. And then we have to take the derivative of, let me write this in red actually. So we just took the derivative, so let's do this. We just took the derivative of e to the negative x, and we'll scroll down a little bit. And right now we were left with just e to the negative x. But then we have to take the derivative of the exponent. Now remember, I wrote down on the previous video, or one of the previous videos for chain rule, that the derivative of e to the power of f of x is really just chain rule. We rewrite the exponential function here with the exponent, and we're just taking the derivative of that exponent. So that's what we're going to do. So we already rewrote e to the negative x. So we're done with this part here. Now we have to take the derivative of the exponent, which is just negative x. And that's just going to be, that's just going to be negative 1. So we're going to put negative 1 here, or we can just rewrite this as negative e to the negative x power. So that is our final derivative there. So let me erase what is in red over here. I'm going to keep the exponent 1 there. Go back to my pen here. And that will be negative e to the negative x. So that is also rewritten as negative 2x e to the power of negative x times sine x squared minus. So now transferring this negative over to the left side, we can write the exponential function first, I guess, and then just write your cosine after that. And this will be your final answer. You could factor out the negative or the exponential function if you'd like. So what that would look like is e to the negative x, and I guess you can transfer out the negative too. It will look better without the negative inside as the first term. So once you do that, you have 2x sine x squared plus cosine x squared, and then close parentheses. And that is your final answer for the first problem. All right, so here is our second problem. This one's f of x is equal to sine squared x squared plus 1. So this one might be confusing, but it's not. Trust me. Now remember, whenever you have a square here, or cube, whatever, what this really looks like is parentheses sine. I'm going to rewrite what's inside of the parentheses, and then close parentheses again. What that square there means next to the sine word is that it's actually being squared, the actual trigonometric function. So these two are the same thing. These two equal the same thing. So now we can see a little better, what we could do with the chain rule here. So the chain rule will be taking the derivative of the outer function first here. I think we're going to need to do it twice. So this is not, what I just underlined is not the outer function. That is actually the inner function right now. So taking the derivative of the outer function is what is on the outside. So without whatever is inside, and with the exponent 2 there. Okay? So again, that's going to be using the chain rule. Is really it's power rule. I know I've been saying in previous videos power rule, but technically I guess we could still say chain rule, I guess. But then all we have to do is rewrite the function that's inside, and there's no more exponent. Well, technically is 1. And then you have to take the derivative of what's inside of the parentheses. And what was inside originally was sine x squared plus 1. Not the one with the squared. Okay, so you don't rewrite that. It's what was inside of really the second one that we wrote. Okay, so again, hopefully the air conditioning is not too annoying here in the background. I literally have it facing towards me. Maybe I shouldn't have it face towards me. Move it over. Fan. over to the left. All right, so now we have to take the derivative of sine x squared. So we're doing this now. That was a really horrible underline there. Let's rewrite that. Here we go. All right, so the derivative of that is going to be chain rule again. So that's going to be cosine of what's inside the parentheses. And then the derivative again of what was inside the parentheses, which was x squared plus 1. And that's going to leave us with cosine x squared plus 1. Derivative of x squared is 2x. And the derivative of 1 is 0. So we're just left with 2x. All right, so that is also rewritten as the final answer. 2 sine x squared plus 1, closed parentheses, times 2x cosine x squared plus 1. You could also multiply this 2x with this 2 and move over the variable, I guess, over to the left as well. So you can have 4x sine x squared plus 1 cosine x squared plus 1. And this is your final answer for the second problem. All right, so this one's going to be a long one. This is going to be, it's going to take some time. So stick in here with me. You'll be fine. So what I like to do is I like to rewrite this in a way or in some form where I have an inner function, it's easy to see, and some outer function. Or where I could use the power rule, at least for the radical functions here. So I could rewrite this actually. I could rewrite this and take away the radical symbol here so that I could have parentheses and a rational exponent. Is it okay to say fractional exponent too? I guess you can say that, but rational is better. Anyways, let's rewrite this where we would have f of x is equal to parentheses x plus the root of x plus the root of x. And then, because I took away that radical symbol there, we can have that rational exponent there. See what I did there? No fractional. I kind of have the intention of saying fractional for some reason. But we'll keep it rational. Hopefully I remember. All right, so now I can use the power rule and continue with the chain rule. I think we're going to need to do this twice. The chain rule is technically 3 times here, but I mean, the last root symbol is the easiest, so we won't have to really go over the chain rule for that last root symbol right here. But anyways, we use power rule first, so that's going to be half. And I guess if you want to rewrite and write the derivative, I guess you can. But I'm going to move ahead because this one will be a long one here. So we're going to write half and then just write what was inside the parentheses. So what was inside the parentheses is our inner function. And that's what we're going to take the derivative in just a bit. So root of x plus root of x, and then cover that one. And then, of course, we use the power rule, so we have to subtract that exponent by 1, and that's going to be negative half. And then we're going to multiply by the derivative. Again, this is where chain rule comes in, of what was inside of the parentheses. And that was x plus the root of x plus the root of x. And as you can see, we're going to need to use chain rule again for these 2 radical symbols. But the first one we do is just x, which is just going to be 1. So I'm not going to rewrite this yet. I'm going to hopefully not forget. But and also it does have a negative exponent or negative rational exponent. And we're going to rewrite that because it's very important there. This one is kind of confusing. So anyways, the derivative of x is just 1, and then we're going to need to use the chain rule again. So I'm going to actually do this in red. Do this last one in red. So we're taking the derivative of this right now. We'll do it up here. Hopefully I don't run out of space. So we have the root of x plus the root of x again, and cover that. And that again we can rewrite with the I'm about to say fractional exponent. Rational exponent. Same thing, I guess. Whatever. And that is just going to be half x plus the root of x. And then, of course, the negative rational exponent, the negative half. Same thing what we did over on the left. Okay, so we are not done. We now have to take the derivative of what was inside of the parentheses. So this is the second time we use the chain rule. And what's inside the parentheses is similar to the first time we used it. So the derivative of x is just 1. So I'm going to rewrite all of this again. I'm rewriting the left side in red. And times 1 plus, and this one here, the derivative of root x, if we can imagine, is just x to the power of half. And that again is just half x to the negative half. And then closed parentheses. All right, here's where it's very important. Let's go ahead and rewrite all of that. So we just took the derivative of this square in red. So that was plus, okay, remember that. We already took the derivative of this x. And that became 1, as you can see there. And then plus what we just found, which I'm going to highlight here. Let's highlight the parentheses as well. Whoops. Let me undo that. All right. There you go. Got everything now. So then that's plus half the root of x plus, or x, yeah, plus the root of x, negative half. And so this is where it gets confusing, where we're going to rewrite it. The one that actually has the negative half is only this term, not the 1. So when we go ahead and rewrite it, we're going to go ahead and put only what was inside the parentheses underneath that 2 and not the 1. Don't bring the 1 down. You're about to see what I mean. But multiply it again by the 1 plus half x to the negative half. And then close the parentheses. Okay. And let's rewrite the what's underlined on the left. So technically speaking, we are done. Like technically speaking, we're done. So that's the entire final answer after deriving the can you imagine? That is what this came out to be. This, and it came out to be what was the last thing we have written here. It's a lot, but some professors don't like negative exponents. So we're going to need to rewrite this. The first one's pretty easy to rewrite. We're going to write the denominator first, so that's 2x plus the root of x plus the root of x. Cover that. And then we have the positive exponent there. And that is, of course, over 1. Then multiply it. Here's where a lot of people get confused. A lot of people, and even I got confused. I put this negative half here once, and I had ended up putting the 1 underneath as well. But it's not. You gotta remember, it's its own term here. Okay, on the right. There's 2 terms. Only the one on the right, which is this one here, has that negative exponent. So we're going to rewrite the parentheses again. 1 plus, and then put the 2 underneath in the denominator, x plus the root of x, and then positive exponent, and then over 1. So again, that 1 on the left right here is alone. Okay? And then we close that. Times 1 plus, again, the 1's alone, 2, and I guess you don't need parentheses for this one, x, and then half over 1. And that is our final answer. If you want to rewrite it with root signs, you can, or radical signs. But we're going to be done there. If you have any questions, let me know in the comment section. If there's anywhere I went wrong or anywhere that I could have explained better, please let me know in the comment section below. I'll see you guys in the next one.